Today we're talking about similar triangles. When two angles in one triangle are congruent to two angles of another triangle, the third angles are also congruent. And this makes the triangles similar. The symbol for similar is kind of like a little squiggle. So identifying similar triangles. Well, if I look at, for example, one, triangles and their angles, 75 here in the little triangle matches the 75 for that triangle, which is the bigger triangle. We also have a 50 degrees, which matches the 50 degrees. So because both triangles have two of the exact same angle measurements, both the x and the y would have to be equal or congruent, which means yes, these two are similar. So to have similar triangles, if all three angles on the inside of two different triangles have a matching pair of the other one, then it would be similar. So if I was, the other way to prove this, to look at the smaller triangle, I would have 50 plus 75 plus x equals 180, because we know that there's 180 degrees in all triangles. And the other one would be 50 plus 75 plus y equals 180. And when I solve either one of these, I'm going to get the x or the y is 55 degrees. So the missing angles for both of these triangles gives me an angle pair that all three of them would have a match. So looking at the second one, so number 2. So this time I see a 63 that matches a 63. And then the 54 and the 63 don't match. So what I need to do is figure out, well, what's the missing x and what's the missing y to see if they do match. So looking at the first one, I would have 54 plus 63 plus x equals 180. If I combine my like terms, I would get 117 plus x equals 180. And when I subtract the 117 from both sides, I'm going to get x equals 63. So this missing angle is 63. So now I feel like I do have similar, because now I have the 63 here that matches another 63, which would tell me that the y angle would be 54. But let's just prove it. Let's just make sure we can see that. So for the little triangle, I would have 63 plus 63 plus y equals 180. So that gives me 126 plus y equals 180. And when I subtract, I get y equals 54 degrees. So yes, these two are similar because there's a matching angle for all three angles. So here's another one. So again, we can start out right away by saying this angle right here matches this angle. We know they're both 90s. So if I just look at my calculations, x plus 42 plus 90 equals 180. 42 and 90 is 132. And then when I subtract the 132, I will get 48 degrees. So that would mean this angle is 48 degrees. So now we're going to look at the next one. Y plus 38 plus 90 equals 180. We get y equals 1 plus 128 equals 180. And when we subtract the 128, I get y equals 52. So clearly, we do not have 3 sets of matching angles. We actually only have 1 pair of matching angles. So therefore, these are not similar. And in the last one, again, we have the two 90s that match. Let's solve the others to figure out. 66 plus 90 plus x equals 180. That gives me 156 plus x equals 180. So x equals 24. So I feel like we have one here, but let's just prove it. So we have 90 plus 24 plus y equals 180. That's going to give me 114 plus y equals 180. And when I subtract the 114, I'm going to get y equals 66 degrees. So the answer here will also be yes. So this next one's a little bit tricky. So we're trying to determine if the triangle JKL, which is laying here on top of JMN, if they are similar. And how do we know? Well, one way to decide this is to pull these two apart. So I'm just going to draw J, K, and L separate from J, M, and N. So I'm going to kind of make them two triangles. So we can kind of really look at these. So one of the important things that I'll see in this picture is this notation. Remember we said this notation means these two sides are parallel. So if you think about it, this JM is actually a transversal to these two parallel lines. So what we know about the transversal and what it would create is that it actually creates corresponding angles right here, which means they are equal, which means JMN as an angle is congruent to JKL. And then there's also another transversal right here cutting through these two parallel lines, which is causing this angle and this angle to be corresponding angles, which means they are the same. Okay, so that means this angle right here is also the same as that one. And then if you really think about this, the first angles that we looked at, this angle right here is the same of the JKL triangle as it is with the JMN triangle, because really you can see it's the same for both. So that one is the same. So here's how I would write this to explain this. So here is angle, and I'm going to write KJL is congruent, because it is the same angle, as MJN. Then I'm going to write angle JKL is congruent to angle JMN, and JLK is congruent to JKL. NM. So when we have three angles that match in two different triangles, we would say yes, they are definitely similar. Okay, so it's using the knowledge that we learned about the transversals with the parallel lines and kind of pulling the two apart to kind of see them as two different triangles. It's hard sometimes to see them on top of each other. So then we have this thing called indirect measurement, where we use similar figures to find a measurement or a distance that is difficult to find directly. Like we look up in a tree and we're like, well, how tall is that tree? And it's hard to tell from the ground. We use similar triangles to try to solve that. And we can do this with similar triangles because, and we haven't used this yet so far in this video, once we know that the angles are the same inside the two triangles, the sides are in proportion. So that means we can make proportions to find a missing side if we know the other three sides. So that's important for that. Okay, so now we want to look at the situation here. We are planning to cross a river to know how far it is to the other side. You take measurements on the side of the river and make the drawing below. So we can definitely see some things. We can measure from here to here, which is 50, from here to here, which is 40, from here to here, which is 60, and here to here, we don't know. Okay? So here's what I want to do, is I want to know if these are similar. So first I want to look at the two triangles. So triangle ABC, A, B, C. So this is triangle ABC. Is it similar to DEC? So again, we need to know, do we have three matching angle pairs inside of the two? Well, I definitely know I have one of them because I can see a right angle in both. So we can see ABC is congruent to DEC, right? Because we can see these right angles. So here's the other one, and we learned this when we did our transversals and parallel lines and our angle measurements. Here we have two intersecting lines, right? And we talked about intersecting lines form vertical angles right here. So those two angles are also going to be congruent. So I'm going to write D, oh, I'm sorry, we won't go with D. Let's go A, C, B. So this angle right here, we'll do the two lines, is congruent to D, C, E. Now I don't know what that measurement is, whereas I know the other one's 90 because it has the symbol. I don't know what that measurement is, but because they are vertical angles, then I know they are congruent. And then what we said was, if I have two pairs, therefore we know that the last pair also is. So then I would know that BAC would have to be congruent to EDC. And again, I don't know what those measurements are. I don't know what that degrees is. But it does tell me, that's how I know that they are similar. So then the last part of this question says, well, what is that distance across the river, which is the x? We don't know what this is. We couldn't measure it, but we were able to measure these three pieces. And this is where we're going to set up our proportion. So you can set proportion in many different ways. We already talked about this earlier in this year. What we're going to do here is set up a proportion of similar information to try to find the missing information. So what I'm going to do is put my information from the little triangle down to the lower right. On the side, I have 40 compared to 50 from the other picture. So this side's height compared to this one is the same as the x from the little triangle to the 60 from the other one. So this would be the same side over here, would be the same corresponding side. So this would be a proportion that I could use to solve this. Now, this isn't the only one that I could use. There are other ones I could use, but I'm using this one. Now remember, when you do a proportion, you can use your cross products to turn this into an equation to solve. So from here, I'm going to do 50 times x, which gives me 50x. And then I'm going to do 40 times 60, which gives me 2400. And then remember, inverse of multiplying is to divide. So x equals 48. So the missing distance across has to be 48 feet. If you have any kind of questions, please make sure you ask me in class, and I will see you then, and we'll work on some activities with this.